Hello colleagues, my name is Konstantinos Kiritopoulos and I'm the principal investigator of the research project Holistic Management of Risks for Road Tunnels that is described in this paper. It's a pity that we could not come together, but thanks to technology we can at least share our presentations and research findings. Myself, I'm an associate professor at the National Technical University of Athens, at the School of Mechanical Engineering. The School of Mechanical Engineering, the best mechanical engineering school according to the international rankings in Greece, and one of the top 100 to 150 mechanical engineering schools worldwide, is part of the National Technical University of Athens, which has been established in 1837. The National Technical University of Athens has 9 engineering schools, around half a thousand faculty members and approximately 24,000 students. This project is about road safety. It's a consortium of 5 organizations, namely Egnatia Motorway S.A, which is one of a highway operator, one of the longest highways in Greece, with more than 50 long tunnels, long saying more than 500 meters. Tekmon S.A, which is a small company with high intelligence that can share with us very important information technology systems. The National Technical University of Athens and the School of Mechanical Engineering, the research center Demokritos, which is a very well known and established research center in Greece, and of course the University of Ioannina, at the School of Mathematics, where it has the main responsibility in this project for the algorithms, etc., that we're developing. So road accidents is still a very important problem worldwide, and this is not different in Greece. We have approximately 76 deaths per million inhabitants, when the European average is 50 on the road. Greece is doing much better in the last years than it was before, but still we have way to go. Specifically for road tunnels, this is a very important area because Greece has plenty of them. The last 10 years, more than, around 100 tunnels in Greece exist currently. Most of them have been developed in the last 10 or 15 years. And the problem with tunnels is that if you have an accident in a tunnel, that can have really severe consequences. It does not necessarily only affect the drivers and users involved, but it might affect significantly the infrastructure itself, as well as plenty of other drivers that are driving through the tunnel. So this project is all about safety in tunnels, and it uses a holistic approach that sees the infrastructure, the operation, the road users, the vehicles, and in this complex system that we have, we find safety as an emerging property. And with what we are doing, we are trying to improve this safety. The main research aims are to support the control rooms of road tunnels to respond adequately in case of potential fire incidents, to develop educational aids for the training of road users, and of course to investigate, as I said, the road tunnel operation through a systemic view as a system. Control rooms exist for almost all the tunnels which are longer than 500 meters. And there is European legislation now that is in place, so all around Europe the tunnels that are significantly long, or they have very high volumes of traffic, they have to be monitored by control centers. And in these control centers, you have the operators who have the very difficult task of interfering and guiding the users when something goes wrong, or on the other hand, use the equipment and try to alleviate the problems that occur. Now, the project has four main axes. This is a quite large program that we're trying to conduct. We're now midway into the project, and today I'm describing the project and I'm sharing some of the results that we have. So the four axes, the first one is about educating and informing tunnel operators and of course the public. The second one is to examine the fire behavior in case of an accident where fire occurs inside the tunnel. Of course, we do understand that this is probably the most important issue in tunnels, fire. And the third one is analyzing users' evacuation process. We're trying to understand how the evacuation is happening and try to see whether people with specific equipment of the tunnel, they have the right amount of time to exit the tunnel. And the fourth part is about communications during a crisis. So how we communicate the information, what systems can we use, and how all these things can work together. Now, apart from the main philosophy in these four areas, the project consists of five significant axes. So the first axis is about the analysis of the system. So what we're doing is that we study the system and we study the system through STAMP, which is a new model that sees how the information systems and people work together under a system and how the whole operating process is. So we're trying to identify the main issues that can happen during the use of the information system in a road tunnel, and through this identify the main risks that can occur. The other part is that we're trying to develop algorithms, and we have developed specific algorithms. This part was done by the University of Ioannina team and the research center Demokritos, where they have developed algorithms that monitor where the patrol vehicles of the highway are, and when something happens with these algorithms, the closest or easiest to interfere unit is called to go and attend the issue. These applications, they come as mobile applications, and of course there is a dashboard, a data center that gathers all the information and shares it among the participants. The second axis is about road users mainly. So we ran a long study, a significant study. We got around 1,500 filled-in questionnaires about the knowledge of users on how they should react in case of emergency, or how they usually drive within tunnels. Some very important conclusions came out of this study. For instance, that road tunnel users do not have a full understanding of how they need to drive inside the tunnel. They are not very well aware of the risks that they face, and definitely they need education in order to understand how to react in emergency situations. So, for instance, one of the basic rules that it is when you have a one-way tunnel, you never make a U-turn if the road ahead is blocked. It seems that there is a significant amount of users that would violate this. At least this is what they say that they would do if they find themselves in front of such a situation. Now, another thing which we're doing right now, as you can see in the photograph, we are developing something like a game, a serious game. We're using virtual reality technology, and we are trying to model a car which is passing through the tunnel, and we're presenting some scenarios to the users so that we can make them aware of what can go wrong on one hand, and then to show them how they should react in each of these situations. The third axis is mainly about fire, and this has two parts. The first one is trying to assess to assess how a fire would work under specific circumstances, how the equipment will work, and in general we're trying to model with CFD, so 3 dimensions, what is happening, how fire evolves, and what is happening inside the tunnel in case of a significant fire. So we're talking fire of 100 megawatts or similar. That information is used so that we can study the evacuation and how much time people have to react in case of a fire in a tunnel. And also we're trying to model their behavior, so to see if they're going to use the emergency exits or they will try to exit the tunnel from the tunnel portals and so on. Another area that we study in this axis, and we have very good results as well, is trying to monitor the dangerous goods vehicles, the heavy good vehicles that are carrying dangerous goods, and try to see if we can capture through photographs the kind of dangerous goods that are transported throughout the tunnel. This is very important for 2 reasons. The first reason is that we need this information when we are running the risk analysis for road tunnels. So this is a very important information for practitioners. But on the other hand, when you have an emergency, if we manage in the end to make this real time, we will have an idea if something goes wrong, what kind of dangerous goods have been inside the tunnel when the emergency occurred. And this information would be really very, very, very significant for the fire brigade and all the emergency services. The fourth axis, which is mainly developed by Tekmon S.A, which is our intelligent company, let's say, is the part of communication. So we develop a system that will be able to share the appropriate information in the appropriate time to all the stakeholders involved. This includes the emergency services, also of course the control room, and all the patrol vehicles of the highway operator. This is very important because it helps the emergency services and the appropriate people that are the first aid respondents to coordinate their actions and act together as a well-functioning team. In the fifth axis, this photograph is from previous drill that we have done. not as part of this project, but this is hopefully something that we will achieve to do in this project in the future as well. We have the pilot application. And we are practically one step before this. Hopefully at the next MOSIM I will be able to report more on what happened in the drill that we're planning to do. And we will try to apply all these new systems that we are developing and try to somehow measure their effectiveness. It's going to be a real-life simulation of all the tools that have been involved and have been developed throughout this project, and will give us information on what works, what we can do better, and what will be our future research endeavors. To conclude, this project hopefully will help in the improvement of safety operations and will help in the optimization of the relevant processes at the end of the tunnel operator, but also it will help educate tunnel users on safety measures and the relevant procedures. We know very well that most of the times accidents involve human errors, and we also know very well that especially when we're talking about tunnel accidents, self-rescue, so what the users will do, is of utmost importance for alleviating unfavorable outcomes of such accidents. And of course, we have the potential contribution supporting tunnel operations and emergency services to confront fire incidents successfully. That is probably the most important outcome of this project. So these are our partners. The full name of the project is Holistic Management of Resources and Emergencies on Motorways and Road Tunnels through an Integrated Intelligent Technology System. These are our partners, as I referred to them before, and we're very grateful to Greece and European Union for funding this research under the program, which is the Operational Program on Competitiveness, Entrepreneurship and Innovation. Thank you very much. Thank you for your attention. I hope that I will be able to answer any questions either at the time of the conference, or I'm happy to answer your questions through email. And of course, make sure to visit our site of the project, where you will be informed about all the research, the recent developments. Thank you for your attention.